Alright, good morning Algebra 2 people. So this particular video is about lesson 1-5. Not totally sure if this is going to be in one video or two. We're just going to see because I don't want to go longer than 30 minutes or it cuts off. So we're going to be in section 1.5 solving both absolute value equations and absolute value inequalities. So I might break it up into two parts. Part 1's equations, Part 2's inequalities, so that I know for sure that I don't run over time. So I got my first 4 examples up here for you guys, and you can see they're all absolute value of some sort, starting out as reasonable as I can with just absolute value of x equals, absolute value of x equals, and then progressing to 5x minus 4 is inside the absolute value sign, and negative 2x minus 1 is inside the absolute value sign, and going from there. What we are going to now understand, using a little bit from the previous lesson, which was graphing, absolute value is the distance from 0. So basically what we're asking here is, what numbers, plural if possible, have an absolute value that's 4? In other words, what are the numbers that are 4 spaces away from 0? Well, there should be 2 numbers that are 4 spaces away from 0. Positive 4 and negative 4 are both 4 spaces from 0. So what you're doing is you're accounting for the distance in question is 4. Which one puts me at the 4? Which one puts me at the negative 4? Because they're both the same distance from 0. So we always take what's in the absolute. So the technical solving technique is the absolute value could land me at 4. That's 4 spaces away from 0, or the absolute value thing could land me at negative 4. Both of these have a distance of 4. Both of those have an absolute value. See, I can use the words absolute value and distance interchangeably because they are talking about the same thing. And the nice thing about those is that's it. Because see, there's the only thing inside the absolute value symbol is the x. So same story here. I just wanted you to see an extra example. The distance in question is 11. Well, there's two numbers that are 11 spaces away. 11 and negative 11. So in other words, whatever the absolute value says it equals, you set it equal to that number and negative that number because they're both the same distance from the middle. There's the 11 over here, there's the negative 11 over here. And it just so happens it just says x in there, so it leads right to an immediate solution. Now it's going to change. So I'm talking now about the absolute value of 16. Folks, there's 2 numbers that have the absolute value of 16. 16 and negative 16. This is the absolute value part. I want to know, when does this equal 16? Because that absolute value is 16. And when does this under here equal negative 16? Because its absolute value is 16 also. So I list 5x minus 4. When does that give me 16? And when does it give me negative 16? Sorry for I could have used more space up here. I didn't have to scrunch it all together. So when does the absolute value part give me 16? When does it give me negative 16? Solve these 2 equations independently. Please understand, and you should be okay with equation solving. We've already done that lesson. This particular solving for x requires us to add 4 and divide by 5. Both scenarios take the same steps, but it's a different number over here for each scenario. So if I add 4, I get 5x equals 16 plus 4, or 20. Divide both sides by 5. 5 divided by 5 is 1x, and 20 divided by 5 is 4. I get x equals 4. That means if I plug that back in here, the absolute value should come out to be 16, and it does. If I plug that 4 right back into there, that means 5 times 4, which is 20. 20 minus 4, which is 16. The absolute value is 16 is 16. This other piece right here, I add 4. That cancels. I get 5x equals negative 16 plus 4 is negative 12. Divide both sides by 5. And I get x equals negative 12 divided by 5 is 2.4. Negative 2.4 exactly. Now this one's not as friendly to check. So I can get out my calculator if I want to do a good accurate job and say, hey, what's 5 times negative 2.4 minus 4? Okay? 5 times negative 2.4 minus 4. And it comes up negative 16. The absolute value of negative 16 is 16, and there's my two choices. See, this answer puts me at the location of 16. This answer puts me at the location of negative 16. Both of them 16 spaces away from the middle, 0. Lastly, this is not a whole lot different than example 3. We're talking about an absolute value of 11. So either this absolute value, I want this to equal 11 because its absolute value is 11, or I want this to equal negative 11 because it has the same absolute value. So we're going to write down negative 2x minus 1 equal to 11. That talks about putting me at the 11. And this talks about the solution that puts me at negative 11. And then I solve. Both of these solves are going to require you and me to add 1 and divide by negative 2. So if I add 1 to both sides, that's out. I get negative 2x equals 12. Divide both sides by negative 2. Negative 2 divided by negative 2 is 1x. And 12 divided by negative 2 is negative 6. There's that one. Same exact steps here, just a little different number here to pay attention to. Add 1. Negative 2x equals negative 11 plus 1 is negative 10. Divide both sides by negative 2. Negative 2 divided by negative 2 is 1, 1x. And negative 10 divided by negative 2 is positive 5. Folks, one of these answers will give me the number 11, which is 11 spaces from 0 on the number line. And one of these answers will give me the negative 11, which is also 11 spaces from 0. Hence, they have the same absolute value. So if I plug in negative 6 just for a quick check right there, that's negative 2 times negative 6, which is 12, positive. 12 minus 1 is 11. Absolute value of 11 is 11. 5. Negative 2 times 5 is negative 10. Negative 10 minus 1 is negative 11. The absolute value of negative 11 is 11. See, one answer gives me the 11, one answer gives me the negative 11. That's my two distances. Okay, I'm going to pause and get a couple additional examples up here. All right, here we go, people. We got the next and final 3 examples that cover absolute value equations. Now, you can look at these 3 examples quickly and realize that there's additional things on the left-hand side of the equation besides just the absolute value. So, for example, the first 4 examples where absolute value is something equals. This one's got the absolute value, but then there's that minus 5. Okay? And then this one's got that absolute value, but it's got this that's not part of the absolute value. And then this one's got both of those issues, a number in front and that number. See, we can't split the problem up into the 2 pieces of absolute value until the only thing on the left-hand side is the absolute value. Nothing in front of it, nothing after it, only stuff inside of it. So that means these particular problems, before I split them into 2 problems, which you do every time, split them into 2 problems, there is a step or 2 first. This question, that's not inside the absolute value symbols. That needs to be dealt with now. That means I need to add 5 to both sides. So add 5. Absolute value of x plus 8. That's out. 2 plus 5, 7. Now the absolute value covers the entire left-hand side. I'm ready to split the equation. 7 versus negative 7. So x plus 8 can be located at the 7, because that's 7 away from 0. And x plus 8 can be located at the negative 7, because it's 7 away. One's over here, both 7 away from the middle. Solve those two equations and you got your two answers. Subtract 8 here. You get x equals 7 minus 8, or negative 1. Subtract 8 here. And you get x equals negative 7 minus 8, or negative 15 here. And you can check both of those back in the original. If you plug it in, it's negative 1 plus 8, which is 7. The absolute value is 7. 7 minus 5 is 2. Negative 15. Negative 15 plus 8 is negative 7. The absolute value of negative 7 is 7. 7 minus 5 is 2. They check. Okay? This one. I got a number out front, which implies multiplication. That means to deal with this number, I divide. Don't say, oh, that's minus 5. Let's add 5 to both sides. That's not a plus or minus situation like this was. That is directly in front of the absolute value symbol, which implies multiplication, which to deal with it means divide. So you guys, right off the bat, I am dividing both sides by negative 5. Negative 5 divided by negative 5 is 1, so one of those things, which is absolute value 4x plus 3 equals negative 115 divided by negative 5 is going to be positive. Let's see, that goes in there 2 times 3. 23. Okay, probably should check my math. I'm usually pretty good mentally. 115 divided by 5, 23. All right, good. Now the only thing sitting here is the absolute value piece, so the number of comparison is 23 versus negative 23. 4x plus 3 equals 23. 4x plus 3 equals negative 23. And we solve those, same solve, minus 3 divided by 4, but solve that for both equations. So minus 3 gets us 4x equals 23 minus 3, or 20. Divide both sides by 4. 4 divided by 4 is 1x. 20 divided by 4 is 5. Over here, still subtract 3. That's out. Negative 23 minus 3 is negative 26. Divide both sides by 4. 4 divided by 4 is 1. 1x, and this is negative. Let's see, 6 with the remainder, 6.5. And I should always on video double check that, because if I was in class and made a mistake, a hand shoots up and they're like, you know, you always want to make sure that I'm doing things right. So negative 26 divided by 4, negative 26 divided by 4, negative 6.5. Okay, so we're accurate. So the last example here, people, in terms of equations, has both scenarios, or both issues. You see the absolute value right here. You see that it's 1 minus 5x in there. But there's a 6 out front here, there's a minus 9 out here. You must deal with those two things first before you do any, this is not 57 versus negative 57. Not until the absolute value is isolated. So you guys, we have to add 9 divided by 6 first right now. So add 9. So we get 6 times the absolute value of 1 minus 5x equals, because that's out, 57, 66. Okay? Divide both sides by 6. 6 divided by 6 is 1, so we have one of these things now. And 66 divided by 6 is 11. Now we're ready to split the question in the number in question is 11. 11 versus negative 11. And please understand, question 7 is like the combination of 5 and 6 in one problem. Question 5, we only had to do the add to both sides. Question 6, we only had to do the divide on both sides. Well, number 7, we had to add to both sides and divide on both sides before we got into the true absolute value work. Now we're going to finish that. Again, it's going to be this absolute value versus 11 and negative 11. So it's going to be 1 minus 5x. When is that 11? And when is that negative 11? Now, you need to be careful here. I added a couple of things, twists and turns. We're not used to always seeing this as 1 minus 5x. It looks backwards. You're moving the 1 first. That's your addition subtraction number. And folks, that's a positive 1, so you're subtracting 1 from both sides. At reduce, and watch, that sign's with that. That needs to stay negative 5x equals 11 minus 1 is 10. Divide by negative 5 on both sides. Negative 5 divided by negative 5 is 1x equals 10 divided by negative 5 or negative 2. Okay, I hope we can see that. I think I got the camera. Okay, we can see that. Same steps. Subtract 1, divide by negative 5. Subtract 1. That's out. That's negative 5x equals negative 11 minus 1, which is negative 12, divided by negative 5. Negative 5 divided by negative 5 is 1x. This is going to be positive. This is going to be 2.4. And there's that. Okay? So that's how that all works, people. Absolute value equations. I am going to stop this video right here because I'm at the 17-minute mark, and I have probably that much to talk about in the inequality section. I'm going to go over the time limit for how these videos work. So that is the end of solving equations. Remember, you can back this up and stop at anything and re-listen and make sure you're hearing all the steps that you're supposed to be doing. I think I'm including those. And sometimes just hearing them a couple times might help. All right, that's it for this segment. Thanks, guys.